Hello, this is our Dynamics class project. We are going to explain rocket dynamics in this project. Firstly, you need to know what is rocket and what is rocket parts. What are rocket parts? First, we're gonna explain about that. A rocket is a spacecraft, aircraft, vehicle, or rocket or bomb. It drives thrust from a rocket engine. Rocket engine exhaust consists entirely of rocket propellant carried inside the rocket. Rocket parts. A rocket generally consists a launch lock, parachute, solid rocket engine, engine mount, recovery wedding, nose cone payloading, shock cord, body tube, and fins. In these photos you can see what part and where it is. And the flight of the rocket. This is an important topic for rocket launches. During launch, the thrust of the rocket engine is greater than the weight of the rocket because rockets need to fly it, you can see in the picture, and the net force accelerates the rocket away from the ground. Unlike full-scale rockets, model rockets rely on aerodynamics for stability. A launch rail is used since the velocity during launch is too small to provide sufficient stability. The rocket begins a strong ascent. The thrust is still greater than the weight, but as the speed increases, the lift and drag forces now act on the rocket. And if you look at this picture, you can see where the progresses are.
Hello, my name is Berkay. I will continue to present our project. Our next topic is the fundamental forces acting on the rocket. In flight, a rocket is subjected to four forces: weight, thrust, and the aerodynamic forces, lift and drag. The magnitude of the weight depends on the mass of all of the parts of the rocket. The weight force is always directed towards the center of the Earth and acts through the center of gravity. The magnitude of the thrust depends on the mass flow rate through the engine and the velocity and pressure at the exit of the nozzle. The thrust force normally acts along the longitudinal axis of the rocket and therefore acts through the center of gravity. You can see these force in the picture on the right side. The magnitude of the aerodynamic forces depends on the shape, size, and velocity of the rocket and on properties of the atmosphere. This is variable. In our next topic, I will try to explain the launch of the rocket and the forces and equation it is subjected to. The rocket launch principle is based on Newton's third law of motion. For every action, an equal and opposite reaction occurs. When a rocket is launched, the combustion products from the rocket's exhaust are pushed backwards at high velocity along with the thrust. This motion causes the rocket to advance in the opposite direction. The movement of the rocket is constantly dependent on the thrust of the combustion products. Therefore, during the combustion process, the thrust is generated and the rocket moves forward. The rocket's acceleration during takeoff can be determined by applying Newton's second law of motion. Using knowledge of dynamics and brief algebra, for a vertical launch, there is no net horizontal force, Fh, on the rocket, and the net vertical force, Fv, is equal to thrust minus the weight. You can see the formulas used below. Also in the photo on the right side, you can see the forces acting on the rocket and the direction of these forces. The forces on a model rocket change dramatically in both magnitude and direction throughout a typical flight. During the powered portion of the flight, the rocket is subjected to the forces of weight, thrust, and aerodynamics, just like an aircraft. Remember that lift is defined to be the aerodynamic force that is perpendicular to the flight direction, and drag is defined to be the force opposite to the flight direction. Comparisons of aircraft and rockets show that, first, the flight direction for an aircraft is normally horizontal, parallel to the surface of the Earth, but the flight direction of a model rocket is normally vertical, perpendicular to the surface of the Earth. Secondly, for a rocket, the drag and weight forces act in nearly the same direction. For an aircraft, the drag is nearly perpendicular to the weight. Thirdly, the rocket engine must generate enough thrust to overcome both the weight and drag of a powered rocket. When the engine runs out of fuel, the model rocket coasts up its maximum altitude. Thank you for listening to me. My other friend will continue our presentation.
Thanks for the Berkay. I will continue the presentation. I'm Arif, by the way. Considering to the forces on the model rocket, the weight is always directed toward the center of the Earth. If the axis of the rocket is perfectly aligned with the flight path, the thrust is along the direction of the flight path, the lift is perpendicular to the flight path by definition, and due to the symmetry of the rocket, will normally have a magnitude of 0. If the axis of the rocket is not aligned with the flight path, generated lift stabilize the rocket and bring it back into alignment. By definition, the drag is directed along to the flight path. The amount of the drag depends of several factors, including the shape and size of the rocket, and the skew of the rocket velocity, which changes through the powered portion of the flight. During powered flight, the flight path will normally be inclined to the local vertical and horizontal. Because of weathercocking, we can then use trigonometry to break the forces into horizontal and vertical components using the inclination angle. The net horizontal force on the rocket is thrust minus the drag times the cosine of the inclination angle to the horizontal. And the net vertical force is thrust minus the drag times the sine of the inclination angle minus the weight. Continue with weak flight. The forces on the model rocket vary dramatically in both magnitude and direction during a typical flight. This figure shows the forces on the rocket during the cruising portion of the flight. The rocket uses all its fuel and the thrust goes to 0. Backward acting on the rocket, the remaining forces are weight and aerodynamic forces. Given the forces on the model rocket, the weight is always directed towards the center of the Earth, when the axis of the rocket is perfectly aligned with the flight path. The lift will be 0 due to the symmetry of the rocket axis flight of the rocket. If it is not aligned with its path, lift is generated which stabilizes the rocket and brings it back into alignment. During upward cruise, weight and drag are opposite to the forward motion of the rocket. The rocket is constantly decelerating and the magnitude of the drag force also decreases as the speed decreases. Eventually, a point is reached where the vertical velocity is 0 and the rocket cannot go any higher. This maximum height can be determined with some simple angle and distance measurement and using trigonometry. Since the weight is still acting on the rocket will begin to return to Earth initially. The velocity is low and now the drag force in the opposite direction of the weight is much smaller than the weight. The rocket gains speed as it falls. As the speed increases, drag increases and soon a point is reached where the drag is equal to the weight but in the opposite direction. Under these conditions, there is net force acting on the rocket, and from Newton's first law, the rocket falls at a constant terminal velocity. The horizontal forces on the rocket is equal to the drag force in the opposite direction of the motion multiplied by the cosine of the flight path angle. And you can see the equations, and the vertical force is equal to the drag force in the opposite direction of the motion multiplied by the sine of the flight path angle minus the weight.
Hello, my name is Ömer. We are together in the rest of the slide. I will talk about forces during recovery. This figure shows the forces on the rocket during the recovery portion of the flight. In order for the rocket to be recovered, it is necessary to slow down the descent with a parachute. When the rocket descends with a parachute, only two forces act on the rocket: weight of the rocket and aerodynamic drag on the parachute. I am starting a new page. Weight is always directed towards the center of the earth. By definition, aerodynamic drag is against the direction of flight. As the rocket descends, drag and weight are forces in opposite directions. If we neglect the effects of the wind on the descending rocket, the horizontal force is zero. The vertical force is the drag minus the weight. The writing part of our slide is finished here. Thank you for listening to me. I hope it was useful.